name is Eric. I'm a teacher at the Asian International School, and today I'm going to teach you about waves and tides. Now, this lesson is based on Unit 4.1 of your book, page 50 and 51. So if you have your book, you can read along. If you don't have your book, don't worry. Everything will be displayed on the screen here for you today. You will need a notebook, so please have that ready, and we can begin. So your goals for today is to find out what causes waves, how do waves affect the coastline, and what are tides and what causes them. First, let's look at this picture. Are all waves the same? Of course not. Some waves are tall and steep, like the one shown in this picture, perfect for surfing. And some waves are low and flat. So, what causes waves, and why are some waves bigger than others? Well, waves are caused by the wind dragging on the surface of the water. The length of water the wind blows over is called its fetch. So in this diagram we can see from one end of the land to the other is the fetch. Now, as the wind blows over the surface, the stronger the wind is, the longer time it's blowing for, and the longer the fetch is, the larger the waves will be, and the more energy they will have. So what happens when waves reach the coast? Out at sea, the waves roll like this. In a gale, they can be over 30 meters high. What is a gale? A gale, or a gale force wind, is a strong wind, between 50 and 100 kilometers per hour, but not as strong as a storm. But when the waves get to the shore, they break. This gives us turbulent water called swash. What does the term turbulent mean? Let me move my head for a moment. Turbulent means violent or unsteady. So here it's describing the white water that's all mixed up on the surface after the wave breaks. So the water that rushes up the sand is called the uprush, and the water that rolls back into the sea is called the backwash. So the wave breaks, we have swash, the white water all mixed up. The water rushes up the sand, this is called uprush, and then it rolls back into the sea, called backwash. If the backwash has more energy than the uprush, the waves eat away at the land, dragging pebbles and sand away. So if there's more energy going back into the sea, it's going to pull material, the sand, the stones with it, back out to sea. And this happens with high, steep waves. So high, steep waves have stronger backwash. But if the uprush, the water flowing up onto the sand, has more energy, the material is carried onto the land, the backwash is not as strong, so it doesn't take it away. And the material builds up to make the beach. And this happens with low, flat waves. So remember, high, steep waves have more backwash, and they will erode the coast. Low, flat waves have more uprush, and they will deposit material and build up a beach. Tides. Tides are something different. Even when the sea is calm and flat, the water level is always changing. Now, this is mainly because of the moon. As the moon orbits the Earth, its gravity attracts the sea and pulls it upwards. The sun also helps too, but the sun is much further away, so its pull is not as strong. The rise and fall of the sea gives us the tides. So look at these two pictures. They're both taken at the same place on the same day. The first one was taken at noon, midday, and here we say the tide is out. So we have a low tide. The second picture is taken 8 hours later, and the tide is in. The water has now covered the beach, we can no longer see the sand, and the sea has reached its highest level for the day. This is called high tide. So low tide versus high tide. When we have low tide, we say the tide is out. When we have a high tide, we say the tide is in. Here are a couple more examples. In the first picture, we can see it's high tide, the tide is in, and the boats are all floating on the water. In the second picture, the tide is now out, leaving the boats resting on the mud. High tides occur about every 12.5 hours, and low tides in between. The drop in sea level from high to low tide is called the tidal range. It changes through the year because the pull of the sea changes as the moon orbits the Earth and the Earth orbits the Sun. So here's a diagram showing the Earth's tides. This is not to scale. The moon is much further away from the Earth than this, but the moon's gravitational pull is pulling the sea upwards. So on the side of the moon, we'll have a high tide. Now you notice on the other side of the Earth, there's also a high tide. This is due to something called inertia, which is a bit too much physics for me to get into in this video. But between the two high tides, we see the low tides. So let's test your memory. What 3 factors affect the height of waves? I'll give you 10 seconds. The strength of the wind, the length of time the wind has been blowing, and the length of the fetch. So make a note of these 3 factors in your notebook. You will need them later on when we do some exercises. So, look at this diagram. We have an island called X at the bottom. There are 3 winds blowing from different directions. If we look at the key, it tells us the orange arrow is a strong wind and the yellow arrow is a light wind. The number inside the arrow is how many hours that wind has been blowing for. So, which wind will produce the largest waves and which wind will produce the smallest waves? And explain your answers. So wind B will produce the largest waves because, remember the 3 factors, it has the strongest wind, it's been blowing for the longest time, 27 hours, compared to the 2 other winds, 10 hours, and it has the longest fetch. We can see it's blowing over a much longer surface area than winds A and C. So, which wind will produce the smallest waves? Your answer should be wind A. So wind A will produce the smallest waves because both A and C are light winds that have been blowing for only 10 hours. But A has the shortest fetch. So A and C are both light winds, lighter than B. They've both been blowing for 10 hours, which is shorter than B. But A has the shortest fetch, so it will produce the smallest waves. So, in your notebook, use full sentences to explain what the following words mean. You can rewind the video to find the information if you don't have your book. Swash, uprush, and backwash. So find the answers, write them down, and when you're ready, we will check. Okay, if you've finished, you should have a similar answer to this. Swash is the turbulent white water that occurs when waves break at the shore. Uprush. Uprush is the water that rushes up the sand after a wave breaks. And backwash. Backwash is water rolling back into the sea after rushing up onto the beach. Remember, stronger uprush means more deposition. It will build sand up on the beach. Stronger backwash will mean more erosion. It will take sand away from the beach. Now let's look at these two photographs. Two beautiful coastlines. But which coast has stronger backwash? A or B? And what is your evidence? Coast B has stronger backwash. Stronger backwash takes away material or erodes the coast. Now, in your notebook, I want you to answer this question. What are tides and why do they occur? You can write the answer in your own words, but please pause the video, write your answer before we check. Okay, if you finished writing your answer, you should have a similar answer to this. Tides are the daily rise and fall of the sea level. They are mainly caused by the gravitational pull of the moon and to a lesser extent by the gravitational pull of the sun. Now here's a challenge. We have a flow chart. It says here, weather affects the strength of waves, and the strength of waves affects the shape of the beach. When the weather changes, the beach slope is changed. But the beach settles back into equilibrium after each change in the weather. So when we're talking about the beach slope, we mean the angle of the sand leading down into the sea. Sometimes it will be more steep and sometimes more gentle. So you're going to rearrange the sentences A to F to explain what happens. Now we'll start with the change in weather, which is storm conditions. So you're going to copy this into your notebook. Pause the video for about 5 minutes or as long as you need. Copy and complete the chart, and then we'll check your answers. Okay, if you've finished, let's check your answers. So we started with storm conditions. So storm conditions will then lead to plunging steep waves. So we have big steep waves plunging with a lot of energy, and that means stronger backwash. Now remember, more backwash means erosion. So erosion of the beach makes a gentler angle. Now there's less sand, so the beach is flat. The gentler slope reduces the speed and energy of the backwash. When we have a gentle slope, the upwash can travel further up the beach and deposit more material. So the waves become less erosive. So we have less erosion and we have more deposition. So this brings the beach back to equilibrium. It becomes balanced again. We're starting out where we were before, until another storm comes and the cycle begins again. So that is the end of the lesson today. I hope you found it useful, and I look forward to seeing you in the next video. Goodbye.